Hi you guys, we're going to go ahead and start Skill 12 series and sequence. So go ahead and get out your notes or wherever you're taking them and the page numbers or slide numbers on the bottom if you have any questions. So this first one asks us, the first three terms of this geometric sequence are as followed. Find the next two terms. So I'm going to look at the pattern that's happening as I go from one term to the other. I'm dividing by 2, or you can think of it as multiplying by 1/2 times 1/2 times 1/2. So times a half is going to give me -8 times another half is going to get me a -4. So we'll go ahead and define more of these later, but we're seeing this pattern and it's asking us just to expand it to find the next two terms. So this is first term, second term, third term, fourth term, fifth terms. Now it's asking me to find the next two terms here. Arithmetic means to add. So I'm adding 5, so I'm going to add 5 again to get 11, add 5 again to get 15. Okay, so we're going to start putting some definitions to these aspects. What you guys have seen so far and what we've talked about is a series. So a series is simply a ordered set of numbers, or like numbers with a pattern. So it's a set of numbers with a pattern. And we're going to start seeing formulas. If it's arithmetic, that means we're adding in between them. If it's geometric, that means we're multiplying to get from one number to the next. So we're going to keep this in mind, and we're going to keep seeing, we're going to keep adding to this as we go. So make sure you have a spot in your notes to write all this down. So as you guys saw on the slide before, we have formulas that can help us find the numbers. So we're going to start kind of learning how to use those. So here's a formula that's going to represent the pattern and help us find the numbers. So it wants the first 4 terms. So this tells us our term number. So A1, I'm going to put a 1 everywhere I see an N. That's going to be my first term. A2, I'm going to put a 2 everywhere I see an N. And it wants the first 4, so I'm going to go ahead and put all the way up to 4. And what this ends up looking like is -12, -4, so if we look at this, we're increasing by +8, +8, +8. So my first 4 terms are this. So back to this chart, we're going to start defining some of these. So what we add each time, a D is the common difference. It's referring to what we add each time. The N, wherever we see an N, That's referring to the term number. So we're going to keep this in mind as we go on. So this is asking for if it's arithmetic, meaning if it has a constant pattern. If it does, what is our common difference? What are we adding each time? And non-arithmetic would mean it doesn't have a constant thing that's being added each time. So let's see if we can find a consistent thing added. Well, that's plus 7, that's plus 7, that's plus 7. So we're going to say our common difference, what we're adding each time, is 7. That's times 5 times 5 times 5. So even though there's a pattern, it's not arithmetic. So arithmetic, remember, that's adding. Go ahead, pause the screen, try this last one by yourself. Minus 6, minus 6, minus 6. So it is arithmetic, and it's negative 6. So this is similar to what we've done before. It just looks a little different. What is the first four terms of the sequence below? So everywhere I see an n, I'm going to put a 1. Then I'm going to put a 2, a 3, and then a 4. We end up getting is a negative 6, a negative, so this is the first, second, third, and fourth term. So now the type we just dealt with, sorry if I go back, we multiplied by 5. So this was like times 5 times 5 times 5, and this is where I see the 5 show up in the equation. So we're going to go ahead and recognize that in our formula chart. That R, we call that the common ratio. And that's what we would multiply by. So when I have something like this R, that's referring to the number I'd multiply by. So you want to be adding these notes. The last thing we're going to add is this idea of an A1 is common in both of them. And A1 is just the first term. So now we're going to look at some geometric sequences and decide what our common ratio is, or what we multiplied by each time. Times 5 times 5 times 5. So that would be a common ratio of 5, and we consider that geometric. This divided by 2, or times 1/2, times 1/2, times 1/2, so that would be geometric with a common ratio of 1/2. This was minus 2, minus 2, minus 2, so there's no multiplication, so that would be just considered not geometric. So this says find the 8th term of a geometric sequence whose common ratio is 1/3 and whose first term is 1/4. So I'm going to use this box, and I know that R is 1/2 and that A1 equals 4. So with that, I'm going to go ahead and use that formula. I know that A1 is 4, R is 1/2. So that's my basic formula. Now it wants the 8th term. So everywhere I see n, I'm going to put an 8. And this will get me 4 over... Oh, I made a mistake. That's 1/3. My bad. So if I look at this similar idea, I have a geometric sequence whose d is 4, or d is 3, and a1 is -10. So, or an arithmetic, I'm going to use this first equation if you're going off your chart. So a1, an, so my basic equation would be and then my 18th, I'd plug in an 18 wherever I see n. And I ended up with a 41. This wants me to write a recursive formula for each sequence. So when it says recursive, it's referring to this idea of n minus 1. So that basically means like the term before. So n minus 1 means the term before. And let's just see what pattern we have. So this is times 10 times 10. So I have a geometric. My first term is 10, or 2, sorry. My first term is 2. My r is 10. So what this will end up looking like is, I'm going to show, actually. So I have the formula an equals an minus 1 times r. And in this situation, I know that my r is 10. When it says n is greater than or equal to 2, that means the second term. So this is your first term, and then second term on, you'd use this equation. Let's see what's happening with this one. Times 1/2, times 1/2, times 1/2. My a1 is 16, my r is 1/2. And all I need to fill in is my r for n is greater than 2, or equal or greater than 2 basically means my second term on. So this writes us to write the recursive formula for the arithmetic sequence. So that means arithmetic sequence recursive. So whenever I have is arithmetic, I need a1, and I need to do a1, and then I just need to fill in here the difference value. So I see that my a1 is 40, which is great. Subtract 11, subtract 11, subtract 11. So I'm adding a -11. So that would be my recursive formula. Or we can just write that as an. Sorry, you guys. So last aspect that we need to talk about is this idea that we have sequences. So sequences are when we add terms of a series. So these are the formulas we're going to use, and we'll spend more time talking about those in a second. So this is series adding or multiplying. This is sequence adding or multiplying. So we're going to keep practicing these sums. So when it says sums, it wants series. So it says compute the sum below. And we know that our difference here is what we're doing each time is adding 2. So that means this is arithmetic. So I'm going to go ahead and use this equation. And then I know that what's nice is that I know A1 and AN, my last term. So AN is 170. But what I don't know is what N is. So I'm going to use the equation I'm going to try to figure out, I don't know what N this is. I need to know what N that is. So I know that AN is 170. N is what I don't know, but I know everything else. So I can go ahead and find that. Oh, sorry, my D is 2. So I'm adding the first 89 terms. And that makes this whole thing equal 7,298. I'm going to use that same equation, so this is all my work for part A. For part B, I'm going to use the same equation. I know that this is telling me where to start, where to stop, and the formula. So I know I'm doing 95 terms. I'm summing the first 95 terms. But I need to figure out the first term. And I need to figure out the 95th term. My first term is 8. My last term is 478. And that gets me to 23,085. Okay, so the last one we have is summing geometric. So I can see here that every time I do this, I'm multiplying by 4 by another 4. So I know that I'm going to use this equation, S of n equals a1 and I know that my r is 4, my a1 is also 4, and I can see that my n equals 7. I'm going to the 7th term. So 1 minus 4 to the 7th is how we'd simplify that. And what we'd end up with, if we put this in a calculator, is 21,844. If I did my second one, I'm still using A1 is, I need to find that. What would it look like if I put in the first term? I know my R is negative 1/2. I'm going to my 9th term. My first term would be negative 3/2. So knowing that, I can plug in everything. So I'm going to the 9th term. A1 is negative 3/2. 1 minus negative 1/2. N is 9. 1 minus negative 1/2. And when I simplify that, I get that. Okay, good job.